Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hoping you are hale and hearty. Hopefully you are watching and listening to all the weekly lectures. Soon, inshallah, I'll conduct a video conferencing based class for live questions and answers session, but surely you will be analyzed and scrutinized for what you have studied, so be ready for that. In our previous lecture, we studied the first 4 types of an operating system. Today, we are going to study the rest of the 5 types of an operating system, which are real-type operating system, multiprocessor operating system, parallel operating system, distributed operating system, and embedded operating system. Before moving towards today's topic, let's have a glimpse of the previous lecture. First and foremost, we talked about batch operating system, an operating system which combines together similar type of jobs or tasks or programs in a batch or in a group and executes these similar tasks one by one inside a batch or group in a sequence. There gave you an example of banking system. Then we studied the second type of an operating system, multi-programming operating system, which is a software that loads one or more programs in RAM and allows a single CPU to execute these programs loaded in RAM, reducing CPU's idle or spare time. Multi-programming operating system performs, or it allows the CPU to perform, context switching, means CPU or microprocessor switches between the programs as programs are converted into processes by the CPU. So CPU stores the context or state of one process so that that process can be reloaded when required and execution can be resumed from the same point. CPU also stores the state of all other processes of all other programs in execution so that all the processes can be restored and resumed at a later point. This is how multiple processes or multiple programs share a single CPU. CPU executes one program, leaves it, starts executing second program, executes it for some time, for allotted time, then again switches to first program, executes it, then again switches to second program. This is called as context switching using multi-programming operating system. Next operating system is multitasking operating system, a software that allows a user to perform multiple tasks at the same time or simultaneously on a computer that has a single CPU. As multitasking is an extension of multi-programming, so this operating system allows the CPU to divide a program or multiple programs into multiple subparts, into multiple subprograms, into multiple subtasks, and execute them using a single CPU. A single CPU switches back and forth one by one between the subtasks or subparts or subprograms of the original program and executes them by switching back and forth between these subprograms. Also, this operating system assigns every subjob or subtask a time slice or quantum for execution. Then we studied about the time-sharing operating system. This operating system allows the CPU to execute or allows the CPU to share CPU time among multiple programs loaded into RAM. If a computer plays the role of a server, it has hundreds and thousands of microprocessors installed inside it, as the server actually has. That server can share its CPUs with client computers, with interconnected computers. If a CPU has to execute multiple subprograms or subparts of a programs, the CPU will divide its time among different subprograms and allots time slices or quantums for execution and performs execution of all these subtasks till the allotted time finishes. Fifth type of an operating system is multiprocessor operating system. This is our today's topic, which is a software that controls the operation of two or more than two CPUs, two or more than two microprocessors within a single computer system. As its name indicates, multiprocessor means many processors or many microprocessors or many CPUs. Means a computer can have multiple processors installed inside it. In a uniprocessor system, only one process executes at a time, or in a system which has only one CPU or one microprocessor installed inside it, only one process executes at a time due to the presence of one processor or one CPU inside the computer. While multiprocessing is the use of two or more CPUs within a single computer. This term also refers to the ability of a system to support more than one processor within a single computer system. Now, since there are multiple processors available, multiple processes or multiple programs or tasks or jobs can be executed at the same time. These multiprocessors share the computer buses, sometimes CPU or RAM clock, memory and peripheral devices like input or output devices. Means these multiprocessors share computers' resources among them. With the help of multiprocessing, many processes or many programs can be executed simultaneously, means at the same time. For example, there are multiple processes waiting for the CPU's execution in a single processor or single CPU based computer system. That one CPU or processor will execute the first process, then the second process, then the third process, and list goes on. While in a multiprocessing operating system, each process can be assigned to a different processor, to a different CPU for its execution. If it's a dual core processor computer, then a program's subparts or subtasks can be divided between the two processors or between the two CPUs of a computer for execution. As dual core means a computer having two processors inside it. If it's a Core i3 computer, its multiprocessor operating system will support 3 CPUs or 3 processors, and multiple tasks, jobs or programs would be divided among 3 CPUs for execution. Likewise, in Core i5 and Core i7 computers, multiprocessor operating system would be able to support 5 and 7 processors for execution of multiple programs or tasks simultaneously. In multiprocessor systems, each program or process would be handled by a separate CPU. A Core i7 having 7 processors or CPUs would execute 7 times as faster as a single processor computer. A Core i7 would be faster than a Core i5 computer. A Core i5 computer would be 5 times as faster as a single or uniprocessor computer. Similarly, a quad-core computer will be 4 times as fast as a uniprocessor system, but all these programs or tasks will share a common space, a common memory of a computer. CPU gets data for execution from RAM. RAM acts as a shared memory space for all the programs loaded inside it. Point to ponder upon is this: why we use multiprocessing. The main advantage of a multiprocessor system is to get more work done in a shorter period of time. These types of systems are used when very high speed is required to process a large volume of data, to execute a large volume of data. Multiprocessing systems can save money in comparison to single processor systems because the processors can share peripherals, cables, and power supplies. It also provides increased reliability, increased readability, in the sense that if one processor fails, the work doesn't halt or work doesn't stop, it only slows down. For example, if we have 10 processors inside a computer and one processor or one CPU fails, the work doesn't stop. Rather, the remaining 9 microprocessors or the remaining 9 CPUs can share the work of the 10 processors, of the 10th processor which failed. Thus, the whole system runs only 10% slower as the 10th processor got failed. Other 9 processors or CPUs are now sharing 100% workload. All the processors perform parallel processing or execution as they work simultaneously or parallelly, or they execute the tasks simultaneously or parallelly. Now, let's discuss the differences between multiprocessor operating system and multi-programming operating system. This would clear out your ambiguities. Before moving towards differences, an important thing to tell you about is that multiprocessing operating system enables several programs to run concurrently or simultaneously or at the same time. Unix operating system is one of the most widely used multiprocessing systems. Multiprocessing means the use of 2 or more CPUs at the same time. Dual core, quad core, Core i3, Core i5, Core i7. These computers have 2 CPUs, 3 CPUs, 4 CPUs, 5 microprocessors or CPUs, or 7 CPUs respectively. So they are also called as multiprocessor computers using multiprocessor operating systems. A multiprocessing technique in which multiple processors or multiple processing CPUs in a single computer system work on different jobs. Each CPU works on a different task than the other. As you can see in this diagram, multiple CPUs are executing more than one processes simultaneously at the same time or parallelly. If we decode this diagram, some concepts have been applied here. There are multiple CPUs present and multiple programs are loaded inside a computer, inside the RAM. Each CPU is actually dealing with a different program. Each CPU or processor is busy executing a different program or a different subpart of that program than the other CPU. So all 3 CPUs or microprocessors are basically working simultaneously at the same time but on different programs. They are active at the same time, but each one is executing a different job, a different task than the other CPU. Now, let's talk about the differences between a multiprocessor operating system and a multiprogramming operating system. With respect to execution, if we talk, a multiprocessor operating system handles multiple programs or multiple tasks or multiple processes, in the sense that these programs or tasks or processes remain loaded into RAM and get executed concurrently or simultaneously using a multiple operating system, using a multiple CPU or processor based computer system. If we talk about a multi-programming operating system in comparison, multiple programs, tasks, processes remain loaded into RAM simultaneously using a single CPU, using a single processor. Means multiprocessor operating system executes programs concurrently, and multi-programming operating system loads multiple programs concurrently. Multiprocessor operating system utilizes multiple CPUs or multiple processes for the purpose of execution of different programs, of multiple programs, while multi-programming operating system utilizes a single CPU or a single microprocessor for loading multiple programs into the RAM. Multiprocessor operating system facilitates much efficient utilization of devices of the computer system, either peripheral devices, etc. While multi-programming operating system is less efficient than multiprocessor operating system when it comes to the utilization of certain devices of the computer system. Multiprocessor operating system takes less time to perform tasks. That is very obvious because a multiprocessor operating system has multiple CPUs or multiple microprocessors installed inside it, so they will share the burden of executing the programs among themselves, while multi-programming operating system takes more time to perform tasks, and that is very obvious because it has only one single CPU or processor installed inside it. Multiprocessor operating system provides increased readability or reliability, in the sense that if one CPU or processor fails, there are multiple other processors installed inside the computer which will handle the workload, while a multi-programming operating system, inside this type of system, if a CPU or processor fails, the execution would completely halt or stop because of the presence of only one CPU which actually got failed. Then the multiprocessor operating system is based computers are mostly expensive than the multi-programming operating systems. That is also very obvious because a system which has multiple CPUs or processors installed inside it, that would be more expensive than a computer which has only one CPU or processor installed inside it. Our next operating system to talk about is real-time operating system, an operating system which runs real-time applications that must process data as soon as the data comes, and it provides immediate response to the applied application or to the applied program. Real-time operating system executes special applications, special programs within specified timeline, within specified deadline, with high reliability. A real-time operating system must have well-defined fixed time constraints or limitations, otherwise the system will fail. For example, real-time operating systems are being used for scientific experiments, for medical imaging systems, in industrial control systems, in weapon systems, in robots, air traffic control systems, in airline reservation systems, in defense application systems like radar technology, in internet telephony. They are also being used in ICUs, in hospitals, in heart pacemakers, for radiation therapies, for heart treatments, for patient monitoring, etc. In stock exchange for up-to-date and minute information on stock prices, They're also being used in vehicle control systems for automobiles, ships, railways, airplanes, controls, etc. These real-time systems are also being used in telephones and radio and satellite communication systems too. Uh, Real-time operating systems actually are installed inside all these systems for controlling their activities in real time or providing a real time response to the activities. A real-time operating system is intended to serve real-time applications or to serve real-time programs, to serve real-time events or live events which need live or immediate response. So this operating system immediately processes data as it comes in, or it processes the data as soon as it receives that data. For example, a Richter scale machine, a machine which records the earthquake readings, in that machine a real-time operating system is installed which records the earthquake as soon as it comes. Even if the earthquake is continued, this machine records the intensity of earthquake side by side in live response, getting live earthquake data and immediately processing that data in order to generate the intensity, in order to generate the result of that intensity. Likewise, a heart pacemaker monitor, which you must have seen in dramas or films, as when the patient is admitted in an ICU, a machine or monitor shows the heart rate of a patient. So that heart pacemaker takes live data of a patient's heart and side by side calculates and shows the heartbeat rate through graphics. So in real-time operating system, the deadline is also handled very strictly, which means that the given task must start execution on a specified scheduled time and must be completed within assigned time duration. If a fighter plane's real-time operating system has been given an instruction by the pilot to fire a missile in a second, the real-time operating system of that plane schedules the fire in 1 second and completes the firing within assigned duration, that is 1 second. It is ideal for applications which require to run 24/7. It occupies very less memory and this operating system consumes fewer resources, and its response time is highly predictable. Means if a system's real-time operating system has been given the instruction to fire a missile in 1 second, it could definitely support the system to fire the missile within 1 second. So response time is predictable, mostly error-free, and this operating system performs tasks without errors within deadlines. Real-time operating system of a device when receives multiple tasks or multiple signals or multiple instructions for execution from the user, it creates a priority queue. We have already talked about the waiting queue or priority queue of tasks. We have already talked about that concept in our previous lecture. So a real-time operating system loads the tasks or jobs in that priority queue and arranges those tasks in a priority based sequence so that the CPU of that real-time operating system based computer can execute these tasks one by one in a sequence by fetching them from queue on first come first serve basis. Means the task which has got first place in the priority queue in the waiting list inside the RAM would be executed by the CPU at the first place. The task which has got second place in the priority queue in the waiting list would be executed at second number by the CPU, and the list goes on. But the execution would happen at such a fast speed that an immediate response would be generated or an immediate result or an output would be generated on the spot within a deadline, within assigned deadline. One task after execution by the CPU gets removed from the priority queue, from the waiting list, as it has got executed. So it would be removed by the CPU from the priority queue, while another recent task gets a place in the queue. It gets a place on the already empty space. Coming and coming out of tasks from the queue continues till the complete execution takes place with the help of a CPU. Now let's discuss some differences between a real-time operating system and a time-sharing operating system in order to give you more clarity. And the differences are as follows. A time-sharing operating system emphasizes on providing a quick response to a request, while a real-time operating system focuses on accomplishing a computational task before its specified deadline. A time-sharing operating system allows sharing of resources like CPU, memory space or storage space, or peripheral devices like input-output devices. It allows the sharing of these type of resources, while a real-time operating system does not allow sharing of resources like CPU or storage space or input-output devices. Events are external to the system. A time-sharing operating system allows execution of more than one resources, while a real-time operating system allows execution of a single application at a time. A time-sharing operating system allows the programs to get modified and written by the user, while a real-time operating system does not allow any modifications, as instructions or options built inside that real-time operating system based device would only be used by the user. A time-sharing operating system gives a response to the user within allotted or assigned deadline, as the response would be predictable. A time-sharing operating system generates the response in seconds, but there is no compulsion that the response would be generated in seconds. It could take further time, while a real-time operating system generates the response within defined time constraint, within defined deadline. A time-sharing operating system allows switching to take place among the processes or among the tasks or jobs, while a real-time operating system does not allow switching to take place between different programs. It does not allow the switching to happen between processes or tasks or jobs. A parallel processing operating system is a software that executes programs developed in a parallel programming language, means programs developed in high-level language like C or C++ or Java, etc. So this operating system uses multiple processors or CPUs or microprocessors parallelly, simultaneously at the same time to handle, number one, separate parts of an overall task or separate subparts of a program. Number two, this operating system also utilizes its multiple processors or CPUs or microprocessors in order to break up different parts of a task, job or program among multiple CPUs, which will help reduce the amount of time to run a program. Programs, tasks or jobs are split or divided into multiple subparts, into multiple subtasks, into multiple subjobs, and these subparts, subjobs or subtasks are then distributed among several microprocessors or CPUs or processors which execute these parts parallelly or simultaneously. This operating system, parallel processing operating system, is designed to speed up the execution of programs by dividing the programs into multiple fragments or parts. The devices or systems using this operating system are called as tightly coupled systems. In literal terms, parallel processing means the use of processors or CPUs at the same time parallelly for execution of one program. As multiple CPUs are involved in the execution of one program only, as multiple CPUs or microprocessors work on different parts of one program only, so these CPUs must be in coordination with one another, as the result generated by all of these CPUs would be at the end combined to form a complete result, to form a complete output. Parallel processing is commonly used in mainframe computers or supercomputers, or sometimes even the parallel processing is also used in mini computers due to the presence of multiple CPUs or due to the presence of multiple processors. As you can see, this diagram displayed here, one program has been split into 6 parts. That's an assumption based diagram, a supposition. That's not necessary that a program should be divided into only 6 parts or can only be divided into 6 subtasks or subjobs. A program can be divided into any number of parts. So the parallel processing operating system has now divided a large program into smaller ones, into smaller parts, into smaller subtasks, and this operating system now, through the help of CPU, assigns different parts of the same one program to different CPUs. Breaking up different parts of a task or a program among different processors or CPUs will help reduce the amount of time to execute a program. Every CPU assigns time slices or quantums to each subtask, subpart for execution. In computers, parallel processing is the processing of program instructions by dividing them among multiple processors or CPUs with the objective of running one program in less time. We can also take it as running a process or more than one processors or more than one CPUs. A processing technique, it is actually a processing technique in which multiple processors or multiple processing CPUs in a single computer work together to complete one job or one program or one task by dividing that one program among themselves. Ideally, parallel processing makes a program run faster because all the CPUs or microprocessors execute or work on one program on the subtasks or subparts or sub-programs of only one program at a time. It divides one task into small parts and give every part to a separate CPU. This operating system divides one job across different CPUs, across different processors. If we talk about the differences between a parallel processing operating system and a multiprocessor operating system, then the differences would be, the first and foremost and important difference is that a parallel processing operating system allows multiple processors, allows multiple CPUs in a single computer to work together parallelly to execute only one task or one job. Means multiple CPUs are available for the execution of one job or one task. and that one task is divided into several subtasks or subparts. While multiprocessing operating system allows multiple processors or CPUs in a single computer to execute different tasks or different jobs. Parallel operating system means multiple processors or CPUs can handle only one task at a time, or multiple processors or CPUs can handle different parts of only one program of only one task at a time. In multiprocessor operating system, multiple processors or CPUs can handle different tasks or different programs at a time, or multiple processors or CPUs can handle different parts of different tasks or different parts of different programs at a time. Means in parallel processing, there are present multiple CPUs or multiple processors, but they execute or they work on only one program. While in processing operating system, I was previously talking about parallel processing operating system. While in multiprocessing operating system, there exist multiple processors or multiple CPUs, but they can execute or they can work on multiple tasks, multiple jobs, or multiple subtasks or subparts. In order to make your concepts crystal clear and to avoid confusions, especially among these three types of operating systems, I'm presenting these differences among them. As parallel processing operating system allows to execute one program by dividing that program into parts or subparts by multiple processors or multiple CPUs. Means there are multiple CPUs but only one program, and that one program can be divided into subprograms or subtasks. While a multitasking operating system allows to execute or run multiple jobs or multiple tasks or multiple programs at the same time by only a single CPU. Means there exist multiple jobs or multiple tasks or multiple programs, but there exists only one single CPU. While in multiprocessing operating system, it allows to execute multiple programs or tasks or jobs at the same time through multiple processors or CPUs. Means that is very simple. In parallel processing, there involves multiple CPUs, multiple processors, but they can work on only one program. Each CPU or each processor will be working on a part of that one program, but all of the multiple CPUs would be working at the same time simultaneously on the parts of only one program. While in multitasking, there exists only one single CPU. There is no concept of multiple CPUs in multitasking. So there is only one single CPU, and that single CPU can work on or can execute multiple programs. While in multiprocessing operating system, as its name is indicating, there exist multiprocessors or multiple CPUs, and these multiple CPUs or processors can work on or can execute multiple programs. Means in parallel processing, multiple CPUs can work on one program. In multitasking operating system, a single CPU can work on multiple programs, while in multiprocessing operating system, multiple CPUs or multiple processors can work on multiple programs. Our next and eighth type of an operating system is distributed operating system. An operating system which is used over a collection of independent, networked, communicating and physically separate computational computer nodes. If we deconstruct this concept, we would come to know that this distributed operating system is used in a network where several computers are connected with one another inside a network. Second very important point is that very important concept to grab here is that, as it says, a distributed operating system is a distributed or a distributed system which is divided among different interconnected, networked, separate, having separate nodes or computers inside a network. Means each individual computer in a network holds a specific software subset of the main distributed operating system. Each node or computer in a network has same operating system. Every computer is installed with a subset operating system of the main distributed operating system installed on the server. Every client computer actually has the subset of that operating system installed on the server computer. So distributed operating system is a centralized operating system, but it runs on multiple client or independent computers. Distributed operating system can run on client server network, as well as it can be used in peer-to-peer networks, where in peer-to-peer networks you have already studied in first year that in peer-to-peer networks no server exists, while in client server network a server exists and controls all the client or interconnected computers. So a distributed operating system is a software which manages the operation of a distributed system or network. A distributed operating system allows execution of an application software on different computers in a program, or allows the execution of a program or file on different computers inside a network. Each individual computer in a network is connected with the main distributed operating system installed on a server. Multiple central processors in a server are used by the distributed operating system to serve multiple real-time applications and multiple users, multiple clients, or multiple connected computers. A user at one node or one workstation or on one computer may be able to use the resources available at another node with the help of distributed operating system. Failure of one node or one computer inside a distributed system, inside a distributed network, doesn't affect other nodes. The remaining nodes can potentially continue operations. In client server network, distributed operating system of a server is connected with all the operating systems of connected client computers. Server's distributed operating system is distributed among all the clients. Server takes requests from client computers for running or executing their programs, so that server executes multiple programs or multiple requests of multiple computers. In client server network, distributed operating system of a server allows execution of one client computer's program on any other client computer inside a network. In that case, users of distributed network do not know that on which computer their program is running, as operating systems running on different computers act as one combined operating system. Another case can be like that multiple CPUs or multiple processors of a server are used by the distributed systems to serve multiple real-time applications and multiple users. Distributed operating system of a server automatically balances the load on different computers in the network and provides fast execution if the tasks are divided among multiple clients for execution. But if a task is handed over to a server for execution, server distributes those jobs or tasks among its multiple processors or CPUs for execution. Remember that if a server is a mainframe computer, that is obvious that that mainframe computer can have thousands of processors or CPUs installed inside it. Server can share its resources with clients inside a network. In a peer-to-peer network, there is no such dedicated server computer. All the computers act as independent inside a peer-to-peer network, but as all computers or peers are connected with one another, even inside a peer-to-peer network, any task or job of one computer can be executed by any other connected computer too, or one computer can share its resources with other computer inside a peer-to-peer network too. The CPUs or processors of different computers can communicate with each other. So the difference between a peer-to-peer and between a client-server network would be that in a server-based centralized network, a server is a very powerful computer which controls and maintains and fulfills the requests of all the other computers and executes their programs and shares its resources with all the client computers, while in a peer-to-peer network no such powerful server computer exists. All the peers or all the independent computers are same in power, but they can also share the resources among one another. So with resource sharing facility present in a distributed operating system, a user at one client computer can use the resources available at another client. Likewise, distributed operating system of a client allows a client to distribute its programs or tasks among different client computers for execution. Each client node will execute a specific part of that program or task. An important goal of a distributed operating system is to hide the fact that its processes and its resources like CPU or storage devices, memory or input-output devices, etc., are physically distributed among multiple clients inside a server-based distributed operating system. This is called as transparency of a distributed operating system, that it can hide the fact that its processes and resources are distributed among multiple clients. Distributed operating system has the capability of presenting itself to the users of a network as one combined unit. Means it appears to the users that all the computers of a network, all the clients or nodes of a network use same one distributed operating system. Distributed operating system makes it easy for the user to access resources from other computers too inside the network. Our next and last operating system in the list is embedded operating system. Embedded operating system is an operating system which is built inside or embedded inside the circuitry or hardware of a device. This operating system resides inside a ROM or BIOS chip. You have studied about the ROM or BIOS chip in your first year course. The main purpose of an embedded software is, or embedded operating system is, to make hardware accessible to the software or programs of a device. These softwares or programs basically run on the platform of an operating system. Embedded operating system automatically runs when a device is turned on or switched on and performs specific tasks. Example of an operating system, embedded operating system or embedded software is a firmware software which resides inside a ROM chip, which is installed inside a ROM chip. This chip is actually attached on your motherboard inside the system unit. When a computer is switched on, a common misconception is that operating system is the first software which gets loaded or gets activated, but reality is that is not true. Firmware software is the first software which gets activated when a device or computer is switched on. So software, after getting activated, fetches or grabs the operating system from the hard disk and loads it into the RAM temporarily so that other programs or softwares can run on the platform of your operating system. So embedded operating system develops an interaction between the hardware and the programs, hardware and the software or program interface using a processor or CPU. Embedded operating system firmware performs very basic tasks like configurations or settings of computer clock or input-output devices. The settings or configurations of input-output or peripheral devices too. Every electronic device has an embedded software inside its circuitry, like a microwave oven, or inside a TV, inside a camera, in a washing machine, inside games consoles. In their circuitry, embedded operating systems reside. So an embedded operating system controls the operations or activities of all these devices, because these devices do not have proper operating system like a computer. So these basic electronic or digital devices work with the help of a basic embedded operating system. So at the end of this lecture, we can say that we are done with all the 9 types of an operating system. Inshallah, in our next lecture, we will move forward towards this topic called as functions performed by an operating system. Till then, stay safe, stay healthy. May Allah bless you. Allah Hafiz.